recording of electrical potential of the heart that is coming to the surface of the heart. The electrocardiographic apparatus that was invented by Dr. Einthoven has 700 pounds weight and carried by 5 people. In order to record the electrical currents, you need at least 2 electrodes. These electrodes connected to the cables, to the apparatus. So, just like the other apparatus, we have off and on knob, amplifier, because the electrical currents that is coming to the surface of the body are very low, they should be amplified. We shoot a pen and paper. These are the cables. You see, the cable has its own color, a standard color. Right hand is always red, left hand is always yellow, left leg is always green, right leg is always black. Red, yellow, green, black. For the links. Right, just a traffic light. Right, red, yellow, green, and a right leg is always black in a standard electrical. That is connected to the earth, to the ground cable. Now, V1, V2, 3, 4, 5, 6. V1 is red again. V2 is yellow. V3, green. No. Brown, black, violet. Brown, black, violet. Red, yellow, green, brown, black, and violet. These are the standard colors. Right is red, left is yellow, left leg is green, right leg is black. C1, red, C2, yellow, C3, green, brown, black, violet.
How should I know the place? For example, is
because if you change the place, you will have different deflection.
Yes. So how can I fix the place?
See, the first rib is under the clavicle. This is the second, third, fourth. Let me make it easier. The fifth intercostal space, we will need fifth and fourth. The fifth is under your nipple. One above would be the fourth. Yes. That would be easy.
So I wanted the fourth, right?
The fourth. Nipple is fifth. One above.
Nipple is the
You should touch it.
Yeah.
You do not need to touch. Just see.
No, I wanted to know because it's also important in the future. We are going to that.
We will see in the classroom, in the practical. I will first discuss what we should do. Then we will take a look at the front panel of an ECG apparatus. You see a start and a stop. This is sensitivity.
Yes.
You see? In normal electrocardiography, we should define the standard voltage. The standard voltage is 1 centimeter for each 1 millivolt electrical difference. 1 centimeter or 10 millimeter for each millivolt electrical potential difference. This is the sensitivity or gain. Both have the same. This is sensitivity. And if we want how much is the 1 millivolt, we should make a mark before each ECG lead. We will see. And then mode. It can be automatically started, change the leads, or you can manually change. In automatically mode, 3 QRS complex will be traced and then the lead will be changed. For example, for lead 1, 2, 3, then the apparatus will automatically change the lead 2, 1, 2, 3, lead 3, 1, 2, 3, lead 4. AVR, AVL, AVL, V1 up to 6. For each lead, we have just 3 EQRS complex. Then change the lead. Before each lead, we will have a 1 millivolt mark. So the speed I will discuss. The speed of the paper, I mean rolling the paper, is 25 millimeter per second. The normal electrocardiographic paper speed is 25
millimeter per second. 25 millimeter per second.
So 25 millimeters. Yeah. Again 25.
Rolling speed?
Rolling speed.
What does that rolling mean? What does it mean?
Rolling of the paper that prints the ECG.
Take a look at the paper. The paper in electrocardiography should be scaled. Take a look. There are small squares. Wow, where are you?
They like
Wait.
practical.
Practical? Because you have.
You were right. You were right. Wait. How about the lunch? When we were eating.
Listen. In electrocardiography, you have paper. The paper is scaled, is divided into a smaller division. Each small square in electrocardiography paper, in length, shows you the time. In width, it shows you the voltage. Normal paper speed is 25.
25 millimeter per second.
25 millimeter
Per second.
25 millimeter for 60 seconds. How much small square do we have? How much?
25 small squares.
Yeah.
25 millimeter for 1 second. 60 seconds in during 1 minute. 60 times 25 equals to 1,500. 25 for 1 second. Am I right? How much time is one small square? Did you get it?
Yeah.
Huh? Take a look. 25 millimeter for 1 second. How much would be? How much the time duration for a small square? How much?
0.04.
Is that okay? Is that understood?
Yes.
0.04 means, listen, each small square in time wise, I mean in the length of the paper,
0.04.
equals to 0.04, and 5 by 5 small squares in lengthwise is equal to 0.2 millisecond. 1, 2, 3, 4, 5. 5 times 0.04 equals to 0.2 seconds. And in lengthwise, each small square equals to 0.15, 0.5 millivolt. Two middle-sized square equals to 1 millivolt. This is the paper. Is that clear up to here?
Yeah. Only see it like that. When we see the electrocardiograph, like in this Is that another type of ECG? I know that.
No. See, this is 1 millivolt mark. That would the first you have drawn is the 1 millivolt mark. The first. I will discuss it. This is 1 millivolt mark.
It's the standard that starts with.
This is the standard voltage. This is the standard time. A standard time, a standard
just for
voltage.
oxidation.
This is how to see before attaching the electrodes. You should clean the skin and attach the electrodes in glabrous. Glabrous means part of the chest without any unwanted hair. Even in the men, it is better to use a trimmer or shaver to move the unwanted hair, to have the best contact with the electrodes and the skin. We should use an electrocardiographic jelly in order to have the best contact. The electrodes are divided into two forms. Some are rectangle metals and some are semicircular metals. Rectangle metals are the leads or the electrodes that are attached to the limbs. I mean upper limbs and lower limbs. The semicircular one is attached to the chest. See, right and left and right leg and left leg and left 6 chest leads are 12 standard hexagonal leads. You can also attach the 6 chest leads on the right side if you want to have a better picture from the right ventricle. When you attach the electrodes to the left side, you have a good picture from the left side. If you want to have a better picture from the right side, you can attach it to the right side. Now, we have detached the electrodes. We have attached the electrodes. Now, take a look. Clean the skin, remove the unwanted hair, use the jelly, put the electrodes, right and left leg, right leg. You should have a good contact with the rear panel of the apparatus. There is a special cable that is connected to the ground. This is called ground cable. See, when we walk at the back of our shoes are actually making a static electricity. A static electricity. A static electricity like a skin, like muscle, like nerves, bring some unwanted electrical currents to the apparatus. In order to remove them, cross them out, to emit them, we should use filters and earth cable. For the static electricity, there is a special filter inside the apparatus with which we can emit, cross out the nerves and the muscles electrical currents to have a very clear electrocardiographic traces. The person should be at total rest without any stress, doesn't take any tea, coffee, alcoholic beverages. The ambient temperature should be
Normal.
Ideal, I mean 25, 26, it shouldn't be more cold or
Hot.
hot because cold causes shivering. Shiverings can produce unwanted noises. Unwanted noises. Then, using the jelly, then start the ECG. We can take automatically or manually. In manually mode, you can change the leads with your hand. 1, 2, 3, 4, 5, 6 traces, then next lead, next lead. It's up to you. شما چرا؟ گفتم بچه ها بیان اونجا بیکاری من دستاتون عوض شد
طبعا كذا لا هو السوق انا
بعدين وين انا ما
We are knitted, not knotted. Tangles or knotted, which one? Tangle.
Oh my. Okay, the other things are for my opinion.
The long ones, what are you talking about? What are you talking about? About the cables?